What do we know about a leap year? Good, it has 366 days. Okay, so we write our conversion and then we draw a T. A leap year, right? Once every 4 years, a leap year adds a day to the year, right? February 29th.
Did we already add a day in 365?
The path we have to take to get from year to seconds, right? We need to go year to days, which we already happen to do. Days to hours, hours to minutes, and minutes to seconds. Okay, so that's the process. So if we want to get rid of days, or in a fraction, if we want to get rid of something, it needs to go opposite of where it starts, right? So days goes on the bottom. And we wanted to go 2 hours, so it goes on the top. Okay. Would you rather tell me how many hours are in a day or how many days are in 1 hour? Yeah, how many hours are in a day, right? So 1 day is equal to 24 hours. Remember, we do no math while we're filling out our T-chart. We just look at these columns and we talk about this equals this, right? We do the math all at the end. So we've canceled days, right? If this is a big fraction, our numerator and our denominator had the same units, so we cancel those units. We now want to go from hours to minutes. Okay, same thing. Would we rather tell how many minutes are in 1 hour or how many hours are in 1 minute? Right, so we say 1 hour is 60 minutes. Okay, so now I've canceled hours. And I want to go from minutes to seconds. So minutes to seconds. Same thing. Usually the bigger unit is getting the 1, and we tell how many of the smaller unit are within that bigger unit. Okay, so now I've canceled minutes. I'm going to go back and check to make sure all of my units canceled correctly. I got rid of days, I got rid of hours, and I got rid of minutes. I'm left in seconds, which is what I want. The unit we want should always be on the top right. Now we do the math by multiplying across the whole top, divide by the whole bottom. Luckily for us, the whole bottom is a 1, right? So there's no need to do that part of the division problem. Are we expecting a big number or a small number?
Big.
Big, right? So think about that. Think that through before we get our answer. We're looking at the number of seconds in 1 year. So we should be expecting a huge number. Okay? So 366 times 24 times 60, which is... Okay. How many feet are in 3.4 kilometers? Okay, so here is where we're looking at a switch between the metric system and the U.S. system. Okay, there's a switch here. So the first thing we do is write what we know, which is 3.4 kilometers. Okay, so open your chart to those U.S. to SI conversions. There's 2 different conversions for length. One is between meters and feet, and one is between inches and centimeters. If I were you, I would choose to memorize one of those things. It doesn't matter which one. Because we always know how to convert from inches to feet, right? And we always know how to convert centimeters to meters. So if we can make it, a conversion between inches and centimeters, and we know that one, then that makes it easy. If you choose to memorize the feet to meters one, that's fine. That makes it easy too. Okay, so I wouldn't do both. You could probably choose one or the other. Okay, so in this case, if we're going kilometers to feet, what would be the most direct path? Kilometers to meters, then to what? Then to feet, right? If we wanted to memorize inches to centimeters, we could go meters to centimeters to inches to feet, right? It would make a little bit longer conversion, but it would work just the same. Okay, so the more direct route for us is just going to be meters to feet. Okay, so if I want to go from kilometers to meters, I know meters is my middleman. Kilometers needs to go where in my T-chart? The bottom. Okay, and meters goes here. Which of those is the larger unit? Yep. Kilometers gets the 1, right? The larger unit gets the 1. How many meters are in a kilometer? 1,000. Okay, so here's kilometers are done. Now I go meters to feet. Okay, the US to metric system conversions don't always follow the rule of the larger unit gets the 1. Okay, so that's a little bit trickier. You can always rearrange your numbers if you want to say that 1 meter is equal to 3 point something feet, right, if you do that division. But usually I say 1 foot is 0.305 meters. Okay, so now I'm done with meters. I'm done with kilometers. I'm left in feet, which is what I want. Multiply across the whole top, divide by the whole bottom. So 3.4 times 1,000. I like to hit enter when I get done with the numerator, done with the top. And then I would divide by 0.305. Okay, because if it's just a big fraction, we're doing top over bottom, right? Top divided by bottom. So we should be expecting a pretty big number here. Okay. That's about what I got. Okay, try this last one on your own. So this is a little bit longer conversion. You got to make a lot of stops to go from centimeters to miles, or miles to centimeters more specifically. Okay, so put that in your notes if you didn't know that already. Okay, so let's try this one on your own. I'll walk around. I'll be there if you have questions, but try and get as far as you can on your own. So density is what we would consider an intensive property of matter. Can we remember back to chapter 1 what intensive properties mean? That's right. It doesn't matter how much of our substance is there. Okay, so it doesn't matter the size of our sample. That's what we're saying. It doesn't matter the size or how much we have of our sample. The density of water is always 1 gram per milliliter, no matter if we have 1 molecule of water or 1,000,000 molecules of water. Right? The density is always the same. The same goes with any other substance. Density is the same regardless of how much of that substance we have. The equation for density is D equals M over V. And M stands for mass. And V stands for volume. Okay, mass over volume. Okay, so when we're talking about the amount of mass per the amount of volume, right? If we've got a lot of molecules packed really tightly together, that means we've got a dense substance, right? Because it's a lot of mass in a really little space. Okay? On the flip side of that, if we have very little or very light mass, little amount of materials or very light substances spread over a lot of volume, right? That means we don't have something very dense. So if something's really dense, the atoms are more compact. Okay? They're more closely spaced together, and if an item or if something substance is not very dense, our atoms are typically spread a little bit further apart. They're not quite as compact. Okay, so that can be a way you think about density. Dense materials typically have very compact, very tightly bound atoms. Less dense materials have atoms that are a little bit spread apart. Okay, what's a typical way that we measure if something is dense or not, right? If it's considered dense or if it's not considered dense. What is a general kind of rule of thumb? Anyone know? Yeah.
Is it like if it's hard?
Yeah, things that are dense usually are tougher. But I'm thinking about in comparison to water. how do we think things are dense or not dense? Yeah.
If it sinks like it's to a lot of water, it's dense.
That's right. If it's denser than water, right, it's going to sink. We usually use water as kind of the standard, right? Density of water is 1 gram per milliliter, and so things heavier than that will sink, right? Things denser than that will sink. Things not as dense will float. So that's kind of the standard there. If something to be considered dense, we think, okay, does it float or does it not? Right? That's kind of our standard there. Okay, any questions? We ready to try some density calculations? Okay. So determine the density of an object that weighs 16 grams and has a volume of 35 centimeters cubed, or cubic centimeters. What do we know about cubic centimeters that we talked about last class? It's the same as milliliters. Good. It represents the same amount of volume. 1 cubic centimeter is equal to a milliliter in terms of amount of volume. Okay? So when we set up our calculation, we would say density is equal to mass over volume. Our mass is given to us here with 16 grams. Our volume is 0.35 cubic centimeters. Okay, keep those units in your problem. Okay. One centimeter cubed is equal to a milliliter. So 1 cubic centimeter equals 1 milliliter. Okay. So what did we get for our answer here? 45.7. Yep, 7.1. And what would our units be? If we take grams and we divide them by cubic centimeters, that means our units are grams per cubic centimeter. That's it. Right? When you would do a division problem, it's top over bottom. That doesn't change with units. Okay, so whatever our units are on the top, we should be divided by our units on the bottom. Grams per cubic centimeter. So that means whenever we go to do a density problem, if our density is given to us, these units have to match. If our density was given in grams per milliliter, what would our mass have to be measured in? Our mass would have to be measured in grams. Our volume would have to be measured in milliliters. Okay, so when we go to do a problem, our units have to match throughout that whole little triangle, right? This is kind of a triangle equation, right? The units have to match within that whole triangle. Okay, so if we're kilograms per liters, mass needs to be in what? If our density was kilograms per liter, what would our mass need to be in? Kilograms. Okay, can everyone say that? Or are we just answering in our head or what? Okay, if density right here, density equals mass over volume, and our density units were kilograms per liter equals mass over volume. To get this unit in our answer, we would have to take kilograms divided by liters, right? That's what our units would have to be in order to get these units for density. Okay? So we need to pay attention to that. If our units for density are given in whatever they are, we need to make sure that these match. Okay? If it was kilograms per milliliter, then this would have to be in milliliters. Right? Okay. All right. Try this one here. We'll do this one together. A certain compound has a density of 3.21 grams per milliliter. I have 24.8 grams. What's the volume? One more time. That's what you're trying to solve for. Okay, so I like to write what I know before I start plugging it into my equation. Density is 3.21. Mass is 24.8. Volume is what I'm solving for. Right? I don't know what my volume is. Okay, so 3.21 grams per milliliter equals 24.8 grams over my volume. All right, I'm trying to solve for volume. So, right now the variable we want to solve for is in the denominator. That's a problem, right? Where do we like to have our variables when we solve for them? In the numerator, right? And by themselves. Right now we don't have those things. So what do we do to move v to the other side? Right? Or to get it in the numerator at least. We're going to multiply by it on this side. And if we do it on the right, we have to do it on the left. Okay? So that means we've canceled here. And we're left with v times 3.21 equals 24.8. Okay, so how do we get v by itself? Okay, divide by 3.21. Divide by 3.21. Okay, so what that essentially leaves me with is volume is equal to 24.8 over 3.21. Okay, do we see how algebraically we got there?
So you really don't use your calculator.
Well, you still have to solve it. You still have to plug it in.
Okay.
Yeah, so that's not our final answer.
Okay.
So go ahead and plug that in. We're just solving for volume, so what should our volume unit be? Milliliters. Did we get 7.73? Okay, and our answer should be milliliters. Okay, so let me show you, and this is why it had to be milliliters. Density was measured in grams per milliliter. Our mass was grams, which is what we wanted, so that means our volume has to be milliliters to make those all match. Okay, let me show you a little shortcut here. Okay, we were at 3.21 equals 24.8 over v. Here's the shortcut. In this triangle type equation, right, we're going to see a couple different types like this, right? And they're not maybe probably called triangle equations, but that's what I call them. Okay, so in this type of equation, if the variable's on the bottom that we're solving for, we're going to switch these two places. That's it. That's what we did, right? But it makes it a lot easier to not have to walk through the algebra that goes with it. So that means v would be equal to 24.8 over 3.21, which is exactly what we just did. We just walked through the algebra to get there. Okay? Now I'm showing you the shortcut is to just switch those two places. Okay? Whenever the variable's on the bottom. Does that make sense?
So if you, like, not that you would want to, but if you did want to, like, write it all out,
Mm-hmm.
you could do it either
Yeah,
way.
you could do it. Yeah, you could absolutely walk through every algebra step. That's fine. Yep. Okay, questions here? All right, let's try one last one here on your own. Okay, I have 0.32 liters of a substance with a density of 2.19 grams per milliliter. What is the mass of the substance? Is there anything that jumps out at you here? Liters. Okay, so my density is given at 2.1 grams per milliliter, yet my volume is given in liters, right? Do these two match?
No.
No, so that's a problem, right? It's a problem. The much easier route would be to convert this, right? We would just convert this liters to milliliters. Rather than try and do anything with our density, we're just going to convert this to milliliters, right? Do we see why we need to do that? Our units have to match, so we need to convert that to milliliters. Okay, so go ahead and do that conversion, and then get it plugged into your equation to solve for mass. Okay, I'll be walking around if you have questions.
And then you find the mass.
Yep, you want to find the mass. So if we want to get mass by itself, we need to multiply by 320 on both sides, multiply by 320 on both sides. We don't need to divide because that's already in the numerator. Okay, listen. So to solve for mass, what did we have to do to those two numbers? What did we have to do to those two numbers? 100.8. What's our units that go with that? Grams. Good. All right, how do we feel? Okay, the reason we multiplied those two numbers is because mass was in the numerator already. We wanted to get it by itself. So we took 320 and I multiplied it on the right side, and whatever I do on the right, I have to do on the left. Okay?